I'm B. Pujita from CSC B section. Here I am telling about the topic nuclear hazards in a disaster zone. Introduction to nuclear hazards. Nuclear hazards refer to a potential risks associated with the release of radioactive materials. These hazards can arise from various sources, including nuclear power plants, medical facilities, and military operations. Understanding these risks is essential for effective disaster preparedness and responsive planning. Next, we are moving to types of nuclear hazards. There are primarily two types of nuclear hazards, radiological and nuclear explosion risks. Radiological nuclear hazards involve the release of radioactive materials which can contaminate air, water, and soil. Nuclear explosion risks pertain to detonation events that can lead to widespread detection and radiation exposure. Next, we are moving to impact of nuclear hazards in disaster zones. The immediate impact of nuclear hazards can include acute radiation sickness among exposed individuals. Long-term effects may consist of increased cancer rates and genetic mutations in affected populations. Environmental contamination can have lasting implications on public health, agriculture, and ecosystem. Next, we are moving to emergency purpose protocols. Effective emergency purpose protocols are critical for minimizing the impact of nuclear hazards. Key measurements include evacuation plans, shelter in place, restrictions, and decontamination procedures. Public communication is essential to provide timely information and guidance during an nuclear accident. Next, we are moving to protective measures for communication. Communities should implement protective measures such as establishing explosion zones and nuclear facilities. Nuclear drills and training exercises can enhance preparedness for potential nuclear disasters. Access to radiation detection equipment and protective gear is vital for emergency responders and the public. Next, we are moving to international guidelines and regulations. Various international guidelines such as IAEA provide guidelines for nuclear safety and emergency purposes. National regulations must align with international standards to ensure comprehensive safety measures are in place. Collaboration between countries enhances the global responsive capability to nuclear hazards. Next, we are moving to conclusion and future considerations. Continuous research and development are necessary to improve nuclear safety technologies and disaster responsive strategies. Public education on nuclear hazards can empower communities to respond effectively in emergencies. A proactive approach to nuclear safety can significantly reduce the risks associated with potential disasters. Next, we are moving to additional case study, communication in the aftermath of Fukushima disaster. Introduction to Fukushima disaster. A Fukushima disaster nuclear power plant disaster occurred on March 11, 2011, following a massive earthquake and a tsunami. This event led to the release of radioactive materials into the environment, significantly impacting surrounding areas. Understanding the contamination and its effects is crucial for assessing long-term environmental and health implications. Next, types of contaminants released. The primary contaminants released included iodine 131, cesium 134, and cesium 137, among others. These isotopes have varying half-lives, affecting the persistence in the environment and potential health risks. Identifying these contaminants helps in monitoring and management efforts in contaminated zones. Areas affected by contamination. The most heavily contaminated area were located into a 20-kilometer radius of a plant, known as the exclusion zone. Beyond the exclusion zone, radioactive materials spread to nearby towns, agricultural lands, and water sources. Long-term monitoring has shown that some regions remain unsafe for habitation and agriculture due to persistent contamination. Next, environmental impact. The contamination has led to significant ecological changes affecting flora and fauna in the region. Radioactive materials have been detected in soil, water bodies, and food productiveness. food products, leading to concerns about food safety. Next, we are moving to recovery efforts have focused on the decontamination and rehabilitation of affected ecosystems, but challenges remain. Next, we are moving to health implications. Exposure to radioactive contaminants poses potential health risks, including increased cancer rates and in other illness. Studies have been conducted to assess the effects on local populations, especially children and vulnerable groups. Ongoing health monitoring and support programs are vital for addressing the long-term consequences of exposure. Thank you for listening.